All right. So today is rational exponents. Basically, we're dealing with rules of exponents here today. This one, you really, really need to get these rules down. Exponents are easy if you know the rules. And the rules all go in both directions. That's an important thing to remember. You can combine things up, you can break things up. So it's important to be able to know these rules and know how to manipulate them. Stuff we do in here, stuff you do later on. I bring it up all the time, but my calculus class, these rules really make a big deal. There's stuff you can do in certain forms and things you have to change them using these rules of exponents to be able to do them. Okay, they're huge, but if you learn the rules and understand the rules, it's actually very easy to manipulate. Okay. So rational exponents, those are going to be the first ones are going to be, or the big new thing. Everything else you've gotten part of Algebra 1. The big new thing today are rational exponents. In a rational exponent, we have whole numbers, negative numbers, and fractional exponents. We're going to deal with fractional exponents today, which are radicals. That's what fractional exponents are. Fractional exponents are radicals. Take them out of radical form and write them as exponents. There are certain things that you cannot do to a radical that you can do to something when it's an exponential form. So you take the radical, rewrite it as an exponent, do what you need to do to it, and then you put it back when you're done. Okay, and like I said, you can't do certain things to radicals, but if you rewrite them as an exponent, it's a piece of cake. And that's really, really extremely useful. It's not that you're changing what they are, you're changing how they look to allow you to do things to them. So there are several rules here. Like I said, most of these you've already had once before. When you're multiplying two things with the same base, notice the bases are the same on almost all of these. Two things with the same base, you add the exponents. That's a to the m plus n. Once again, it's very important to remember these rules go in both directions. So I can rewrite something as two things multiplied by splitting up the exponent as well. I've done that several times, being able to go back and forth between the two. When you're raising, yes?
It wouldn't be 2a after.
No, because when you're multiplying, you only add the exponents because I don't have, 2a would be if I'm adding them, not multiplying. Right? A plus a is 2a. A times a is a squared, because 1 plus 1 is 2, which is what you're doing. You're adding the exponents. Okay. When you raise a power to a power, you multiply the exponents. And the nice thing about this one is you can actually swap the exponents, because the rule says, hey, multiplying means a power to a power. This is technically a to the n to the mth power. You can actually swap the exponents. And I've done that before. Okay. And we will do that later on. I don't know if it's this chapter or the next chapter, but we will do that. When you're dividing, you subtract the exponents. A to the m minus n. And it doesn't matter whether they're negative, positive fractions. It doesn't matter. You add, subtract. Okay. This is probably the one that confuses the students the most. If I have a negative exponent, that makes it a positive exponent in the denominator. Here's what I like to do. The fraction bar is like this magic wand that when something passes across it, the exponent changes sign. So if I have a negative exponent in my denominator, that becomes a positive exponent in my numerator. Okay, you pass back and forth between the numerator and the denominator, the exponent changes sign. Okay. Anything to the 0 power is 1. Okay, and I'm going to put up. Okay, now these next two rules do have different bases, two different numbers. If I have two things that are multiplied raised to a power, that's each individual 1 raised to a power. Okay. You can distribute across multiplication. You cannot distribute across addition or subtraction. We talked about that last week. But if it's multiplication, that's okay. And the same thing holds true for division. Two things divided raised to a power is each thing individually raised to a power. We actually kind of did that with our radicals the other day. That's what we were doing when we split the radicals up, is you're doing that. Now, here comes the new part and the fun part. Fractional exponents. Your denominator is your root. So a to the 1/2 power is the square root of a. Okay. A to the 1/3 power is the cube root of a. A to the 1/anything power, that's the nth root of a. Whatever that denominator is, that's the index on your radical. Now, if you have a numerator that's something other than 1, we have a fraction m over n. The denominator is your root. The numerator is your power. The nth root of a to the m, or you could, and I've done this before, the nth root of a to the mth power, where you take the entire root to that power. It doesn't really matter which one you do first, whether you take it to the power or you take the root. It doesn't matter. Okay. But that is extremely useful. Like I said, in calculus, one of the things we do, one of the big things we do is take the derivative of numbers. You cannot take them of radicals, but if you rewrite it as a fractional exponent, piece of cake. As a radical, you cannot do it if it's in radical form. You must rewrite it in fractional exponent form. But once you put it in exponents, it's a piece of cake. But leaving it in radical form, you literally cannot do. We don't have rules that work for radicals, but we do have rules that work for exponents. Okay, so it's extremely useful to be able to do this. Okay. Questions? Okay, following the rules we did, simplify these expressions. And it's literally just follow the rules. And that shouldn't take too long. X to the 5th, x squared is x to the 7th, add them together. X to the 5th squared is x to the 10th, you multiply the two exponents. X to the 5th over x squared is x cubed, you subtract. X squared over x to the 5th is x to the -3. But we don't like negative exponents in our answers. We always want to have positive exponents whenever possible. There are times when you deal with negatives, but really we like to have our exponents positive in our final answer. So x to the -3 becomes 1 over x cubed. Here's what I like to think about when you're simplifying these things is you subtract because you're doing division. Wherever the larger exponent is, that's where your answer is. 5 minus 2 is 3, but it goes 3 in the denominator because that's where the larger exponent is to begin with. Or you could make it a negative and then move it down later. It kind of depends upon the problem. Another one, x over x to the -5 is 1 over x to the 5th. 1 over x to the -2 is x to the +2. Anything to the 0 power is 1 as long as it's not 0. In this one, you distribute your exponents. So I have 2 to the 5th, x to the 5th, y to the 5th. However, I should write 2 to the 5th as a single number, not a power, because I can figure it out. So my final answer is 32, x to the 5th, y to the 5th. That should be my final answer. And whenever possible, simplify your numeric portions. I can't do anything to the variables because that's all I have. Same thing is true on the next one. Everything is raised to the 5th power. They just stay where they are. So I get 32 x to the 5th over y to the 5th. Exponents are easy if you know the rules. If you don't know the rules, man, you get lost in a hurry. But if you have the rules down, and they're not that many, they're not that complicated, if you have the rules down, exponents are easy. It's one of the easier things that we actually deal with. But being able to manipulate them around really is valuable. Okay, so this one we're going to do numeric evaluation. We're going to come up with a single numeric answer. There's a couple ways to do this, and you can do this on your calculator. Your calculator will let you do fractional exponents. I'll talk about that in a minute. But you should also be able to do these by hand. Okay? When I add 8 to the 2/3, the 2 on the top means that I square it. The 3 in the bottom means I take the cube root. Now, you have a choice. I can square 8 and make it bigger and then take the cube root of that big number, or I can take the cube root of 8 and then raise that to the second power. It doesn't matter. Personally, I like to work with smaller numbers than big numbers. So I would take the cube root of 8 first, and the cube root of 8, if I can think about it like this, is how I can think about it. Cube root of 8 is 2, so I have 2 squared, which is 4. Same thing here. 5/3, the denominator, cube root. The cube root of 27 is 3, so this is 3 to the 5th, which is 243. The next one's complicated. I actually have 3 things going on there. I have the 3 in the numerator of my exponent. I have the 2 in the denominator of my exponent, and I have the negative as part of my exponent as well. The negative means that I have 1 over 4 to the 3 halves. That's what the negative means. It's 1 over that. The 2 in the denominator means that I take the square root. So this is 1 over, sorry, not 4. The square root of 4 is 2, so this is 2 cubed, and 1 over 2 cubed is 1/8. Negative 32 to the 4/5 power. Man, you bet your hiney I'm not going to take 32 to the 4th power and then take the 5th root of that. Because that's going to, 32 to the 4th power is going to be this big ginormous thing, and then the 5th root of that's kind of ugly. But the 5th root of 32, that's easy, it's 2. So this is negative 2 to the 4th power, which is 16. Don't get confused with the negative in the exponent and the negative in front of the number. They do not mean the same thing. Negative in the exponent has nothing to do with the sign of your final answer. Most common mistake students make, oh, it's a negative exponent, my answer is negative. No, it's not. It means it's a fraction. Okay. 16 to the 3/4 power. Once again, I'm taking the 4th root first. So this is 2 cubed. And then 2 cubed is 8. The last one, 8 to the negative 4/3. This is 1 over 8 to the 4/3. And then the denominator means that I do the cube root. So this is 1 over 2 to the 4th, because the cube root of 8 is 2, which means that I get 1/16. Now, on your calculators, you can do this on your calculator. You have one of 2 buttons to do exponents with. You either have a y to the x key, or you have a caret key. That's what that's called. It's called a caret. Okay, that's called your caret key. One of those 2 is an exponent key. And let's say I wanted to do 16 to the 3/4 power. You can do that on your calculator. Type in 16, and I believe the ones that I have here are the caret keys. And then you do the exponent, 3, and there's 2 ways to do fractions on here. Either one will work. You can do 3 divided by 4, put parentheses around the exponents. And that'll give you 8. Okay, that'll give you 8. The other way to do it is your calculators do also have fraction keys. You have a fraction key on there. The fraction key looks something like, I think it's this is what you have for your fraction key. It's a mixed number. And if you hit that once, all it does is rewrite it as a fraction. And you can type it in as a fraction and put parentheses around it. The key is putting parentheses around your exponent. You can raise anything to any power using the exponent key. And like I said, it's either caret key or it's y to the x. One of these two is what you have for your exponents, depending upon which brand of calculator you have. And you can do anything. The key is put parentheses around the exponent. Because if you don't, here's what's going to happen. It's going to take 16 to the third power and then divide that number by 4. Because it follows order of operations strictly. Your calculators are stupid. They do exactly, they're like petulant little children. They do exactly what you tell them to do and nothing else. So you type into the calculator, they follow the rules of order of operations very strictly. They do not infer anything. Little kid's mad at you. You tell them to pick up their shoes off the floor. They pick them up, and they put them on the bed. They said they're off the floor. You told me to pick them up off the floor. When what you meant was pick them up off the floor and put them away in your room. No, they just pick them up off the floor because that's what they do. They do exactly what you tell them to do. That's what calculators are. They do exactly what you tell them to do. And if you don't put parentheses around your exponent, the order of operation would have you take it to the third power and then divide that whole thing by 4. Parentheses are important on this one. Okay. Your turn. Simplify these. You come out with a single-digit number on every one of them. Maybe a fraction. Okay. So 49 to the 3/2. The 2 means I take the square root. So this is 7 cubed, which is 343. It's been a while since I've done 7 cubed. 343. The next one, 4 to the 5/2. The 2 means I take the square root. So that means I have 2 to the 5th, which is 32. The next one I have a negative, so this is negative 27 to the 1/3 power, and the 1/3 just means the cube root. So this is 1/3. This one here, it's negative 8 to the 2/3 power. So I take the cube root of negative 8. So that means I have negative 2 squared, which is 4. 9 to the negative 1/2 means I have 1 over 9 to the 1/2. 1/2 is the square root, so I get 1/3 on this one. And the last one, 16 to the negative 3/2. Means I have 1 over 16 to the 3/2. Gets rid of the negative. The 2 means I take the square root. So I have 1 over 4 cubed, which means I have 1 over 64. Questions? Okay, this part here is actually really easy. All you're doing is rewriting, going back and forth between the first one. You're going to take the radicals, write them as fractional exponents, and it's really easy. Your radical, the index, is your denominator. Your other power is your numerator. So when I have a square root, I have an index of 2 that I don't actually have written there. So this means that I have x to the 5/2 power. Fourth root of m cubed is m to the 3/4. Same thing here. It's a cube root, so it's to the 1/3 power, and everything inside has a denominator of 3. Now the 7 that's here and by itself in the front technically has a 1 for an exponent on it. So that's 7 to the 1/3, y to the 2/3. Same thing on the next one. I have my 2 in front. There's technically technically a power of 1. Okay, we don't write it, but technically it's there. So basically I have all those exponents with a 5 underneath. That's it. 2 to the 1/5, c to the 2/5, d to the 4/5. Now, before we move on, I actually want to go back and look at this first problem. When we were simplifying radicals the other day, and I said, ooh, take 5, divide it by 2, you pull out what's the whole number, you're left with the remainder. Technically, this is what we were doing, is we're doing this, we're rewriting as a fraction. Now you take that fraction and rewrite it as a mixed number. 5 over 2 is 2.5, right? You rewrite that as a mixed number. X to the 2.5, x to the 5/2 is x to the 2.5 power, which is x to the 2nd power times x to the 1/2 power. Because what do you do when you multiply? You add them, right? And when I say the rules do, the rules can go in both directions. So I have 2.5 is 2.5, 2.5. I can split them up into two things, which means I have x squared and the square root of x. This is the simplified form of that, which is what we did the other day. Technically, this is what I was doing. 5 divided by 2. 5 divided by 2 is a 2 with a remainder of 1. The remainder of 1 gives me a 1/2 power. That's technically what we were doing the other day. So we were following the rules of exponents. I just hadn't covered the rules yet, so I didn't show you the rules to do that. But that's what we were doing. Your turn. Rewrite those as exponents. Okay. Shouldn't take very long. The first one, there's a 2 written, there's an unwritten 2 there. So this is y to the 3/2 power. This one is a to the 4/2 power. What do we always do to fractions? We can reduce them. Always reduce fractions if you can. So 4 divided by 2. So that's technically a squared. Okay. I know that's a trick question. Next one is n to the 7/3. This one.
Did you change it to 2 1/3 and then do that?
No, we're not doing that. We're technically not doing that one here. If you were simplifying it, that'd be fine, right? You're just writing as an exponent. So you want to leave it. You don't want to have mixed numbers as exponents. The only reason I did the mixed numbers as an exponent was to show you the simplifying process. You want to always work, whenever possible, in this class with improper fractions. Basically, the only time you use mixed numbers is when you're answering a word problem. I have 5/2 of a pizza. Doesn't make sense, but I have 2.5 pizzas. Does. That's the way I look at them. Okay. The 5 out front means that everything has a denominator 5. 3 to the 1/5, c to the 4/5, b to the 8/5. This one, the same thing, only it's a cube, and the denominator one stays in the denominator. So I have 2 to the 1/3, x to the 5/3, over y to the 4/3. Easy peasy, but extremely important. Can't work with this. I can work with that. The exact opposite. This is the exact opposite. It's very, very easy to do. Your denominator is the index for your root. The numerator is your power. This is the 5th root of c squared. Because I have a 7 denominator on both of these, this would be the 7th root of 2m cubed. Now the negative exponent means that I have 1 over x to the 3/2, and then I rewrite that as a radical in the denominator. So that's 1 over the square root of x cubed. So in the last one, you want to take care of the negative first, put 1 over that, and then rewrite it and get rid of the exponent. Your turn, do those. Okay, let's go ahead and get this done. So the 6 in my denominator, 6th root of b to the first. We don't write the 1 unless we have to. These are all 4 in our denominator, so it's the 4th root of 3 to the first, y cubed, z to the 5th. This one has a negative exponent, so it's 1 over. The 3 means that I have the cube root. The 2 means it's squared. Same thing on the next one. I have a negative exponent, so it's 1 over. And the 5 means I have the 5th root of g. Piece of cake. Extremely important to be able to go back and forth between radicals and fractional exponents, though.